Good evening, everyone. I hope all of you have solved that question. We're going to start with its answer very soon. Some of you have sent it to me, right? And I have responded appropriately. Okay, so let's begin. I'm sure all of you can see the screen. Can you hear my voice? Is the voice clear and loud enough? Okay, very good, fine. Thankfully, I don't have to shout today. Right. So here, let's quickly talk about the answer. Well, equivalent resistance of the whole circuit or of the whole network, that is this one, right, is equal to 6 ohm, right? And this is internal resistance 2 ohm. Okay, so the current in the circuit, will be 8 upon 6 plus 2, that is 8 by 8, that is 1 ampere, right? So current 1 ampere flows here, right? This I is equal to 1 ampere, right? So of course these two are in parallel, so the current must split. So let's say the current here is I1 and let's say the current here is I2, and this I3 will be same as I, right? I don't think anyone has any problem with that, right? So finally the answers are, we get 3 into I1 is equal to 6 into I2 is equal to, here you can see that current I is flowing. So if you just take a resultant of, I mean equivalent of 3 ohm and 6 ohm, you're going to get 2 ohm. So that 2 ohm is there and I flows through it. So we should write 2 into I, right? This is one of the easiest ways to do it, right? ઓછામાં ઓછું લખીને કર્યું, right? હજી આનાથી એ વધુ શોર્ટકટ મને આવડે છે, પણ આ સમજાઈ જાય તો કઈ જરૂર નથી, રાઈટ? અને પછી ખોટા ખોટા તમે કન્ફ્યુઝ ન થઈ જાઓ ને, એટલે હું સાવ લેખા વગર નથી કરાવતો. એનીવેઝ, સો 2 into I means 2. So that's why I1 is equal to 2 by 3 and I2 is equal to 1 by 3 ampere. આ બે કરંટના આન્સર આવી ગયા. I3 તો આવી જ ગયું છે. And voltage is now very easy. Voltage કે તે કરાય V1 equal to V2 equal to ગમે તે લઈ લો, right? Because V1 sorry R1 and R2 are in parallel, બરાબર ને? તો ગમે તે લઈ લો તો ચાલશે. તો આનો આન્સર આવી જશે 2 volt. Okay, by Ohm's law. And for V3, for the third resistor, it's going to be 4 volt because current is 1 ampere and resistance is 4 ohm, બરાબર ને? So that's it, right? This is the whole question. Okay, anything to ask, anyone? Anything to ask? All right, looks like nothing. Okay, right. આ તમને important points મોકલા હતા, બધા યાદ રાખી લીધા ને? Terminal voltage formula and all that. Okay, now the next thing that we are going to talk about today is Kirchhoff's laws or rules. Okay, very important rules. આજનો લેક્ચર આ ચેપ્ટરનો સૌથી ઇમ્પોર્ટન્ટ લેક્ચર છે, બરાબર ને? You have a doubt in 3.2 exercise 3.2 terminal voltage. Okay, Tanay, will you please contact me personally? કારણ કે અત્યારે મારી પાસે ટેક્સ્ટ બુક એટલે જો કે છે એમ તો. Right, anyone else having doubt in exercise question 3.2? Anyone else having, wait a minute Tanay, let me ask others. Anyone having doubt in exercise question 3.2? હોય તો બોલજો તો કરાવું, નહીતર પછી એને પર્સનલી કરાવી દઈશ, એટલે પૂછું છું, શરમાતા નહીં. Okay, all right, let's get done with it very fast. Okay, we have a few, yes, so just get through with it very fast. Okay, 10.2. A battery of 10 volt EMF and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? Okay, and what is the terminal voltage of the battery when the circuit is closed? Okay, Tanay, have you found out the resistance? If yes, you can tell me that answer. That will reduce my work. આવું કંઈક છે, બરાબર ને? 17 ohm. All right, okay, so this is 10 volt and 3 ohm, and this is 17 ohm. That's what you have found because current is 0.5 ampere. અચ્છા, હા, તો પછી શું વિચારવાનું છે? See, this battery is driving the current, right? So this battery is definitely getting discharged. I hope you have understood that, right? તો પછી V equal to epsilon minus IR કરવાનું. So epsilon is 10 minus I, current is 0.5. All right, and small r is 3. I hope that is clear. આમાં કઈ બીજું છે નહીં, don't get confused. Again, when we say 10 volt battery, this 10 volt is EMF, everyone. When I say 12 volt battery, that 12 volt is actually EMF. Okay, anything else, Tanay? Any confusion now? Okay, right, fine. Okay, so let's get on with Kirchhoff laws or rules. તો તમે જોજો, જોરદાર rules છે. They're very 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 easy if you try to understand them. ખોટું ગોખવા નહીં જતા, right? Common sense છે. You are going to discover that these rules are common sense. Okay, so first of all, Kirchhoff's first rule. Okay, this is also called Kirchhoff's junction rule. Okay, right? આ એના બે નામ છે. Kirchhoff માણસનું નામ છે. Okay, so Kirchhoff's first rule or Kirchhoff's junction rule. All right, so what is that? First of all, what is a junction? Look at this carefully. Suppose there is a wire like this, there is a wire like this, and let's say there is a wire like this. So do you clearly see that this point is a junction? Understood? Clear what is junction? Okay, જ્યાંથી બે રસ્તા પડે ને એ જંકશન સીધી રીતે, right? Or maybe something like this. This is also a junction, right? This is crossroads, or you can go in 4 directions, so that's also a junction. Okay, anyway, so that's a junction. Now what does this rule say? No, this is third chapter. Yes, Hodul, that's right. અવિનાશ સેકન્ડ તો કે દી નો પૂરો થઈ ગયો હવે તો બહુ મોડો મોડો જાગ્યો. Are you Avinash or are you an imposter? Okay, so here is the rule. So suppose there is a current I1 here, right? Suppose there is a current I1 coming in like this towards the junction, and let's say that there is a current I2 going out, okay? And let's say there is one more current I3 going out, going away from junction, okay? So put in a very simple way, this is the statement of Kirchhoff's junction rule. Exam માં છાપી નાખજો, માર્ક મળી જ જશે, બરાબર? Sum of incoming currents at a junction is equal to the sum of outgoing currents. Okay, sum of incoming currents is equal to the sum of outgoing currents, right? Okay, બહુ ટેકનિકલ લેંગ્વેજમાં લખવું હોય તો આવું લખાય, at any junction the algebraic sum of currents entering the junction is equal to the algebraic sum of currents leaving the junction. બરાબર? આ બે નો મતલબ એક જ થાય, બરાબર ને? એટલું તો સમજાય જ ને તમને? Okay, Hodel is asking, sir, isn't this statement obvious? That's why I started by saying that it is like common sense. Okay, now you see we are going to talk about why it should be true. તમારી common sense intuition એટલું develop થઈ ગઈ, સારી વાત છે. But why should this be true? Okay, the reason is, I'm writing the reason here. આ reason સમજવા માટે જરૂરી છે. એક્ઝામમાં કોઈ એવું નહીં પૂછે રાઇટ નોટ ઓન કિર્ચોફ્સ રૂલ. ઓકે, આના સમ આવે છે મસ્ત ચકાચક, ભલભલાને મૂંઝવી નાખે એવા. લો, પૂર્વેન્દ્ર કહે છે આપણે ડિસ્કવર કરીને આપણું જ નામ રાખી દે. Okay, the reason is the law of conservation of charge, and that charge is not stored anywhere, right? Over here charge is not stored at the junction. I hope you understand what I'm saying, right? Junction is not something that can store a charge. એ તો વાયર જ છે. તો જેટલો ચાર્જ અહીંથી આમ આવશે એટલો આમ જતો રહેશે ને આમ જતો રહેશે. પાણી વયું જાય કે નહીં, રાઈટ? એવી જ રીતે ઇટ્સ એઝ સિમ્પલ એઝ ધેટ. ઓકે, અને આ બધું એકદમ શોર્ટમાં લખવું હોય તો આવું લખ નાખો, સિગ્મા આઈ ઇનકમિંગ equal to sigma I outgoing. પતી ગયો, હવે આગળ નથી સમજાવવાનો. આવડી ગયું ને? ચલો એક ટેસ્ટ. સપોઝ આવ્યા છે અહીંયા 3 એમ્પિયર, ઓકે, અહીંયા 5 એમ્પિયર, and if this is 7 ampere, then you have to find what's the current here. चलो चलो फटाफट. You have to find what's the current here. Okay, many of you are giving right answer. In which direction? Towards J or away from J? Towards J or away from J? Yes, it's right. Away from J. આમ આવશે 1 ampere. જોઈ લો ટોટલ. ઇનકમિંગ ટોટલ 8. તો આઉટગોઈંગ ટોટલ એ 8 થવું જોઈએ ને. I hope that is very clear. નાના છોકરાઓ જેવું નથી આ? Okay, so this is Kirchhoff's first rule. So glorious, isn't it? This is Kirchhoff's first rule. Clear? Okay, now let's go to Kirchhoff's second rule. Okay, or second law. ખાલી એક વસ્તુ યાદ રાખજો. What's the reason of Kirchhoff's first rule? This one, law of conservation of charge. અને આ સ્ટેટમેન્ટ ગોખી નાખજો. સાવ સહેલું જ છે, કઈ અઘરું તો છે નહીં ને આમાં. બરાબર, યાદ રહી જાય એવું છે ને. આ યાદ રાખી લો એટલે તરત આવડી જશે. Now second rule. Okay, we'll start with common sense. આ એનાથી એક ખતરનાક છે. Okay, Kirchhoff's second rule, which is also called Kirchhoff's, હું જ ભૂલી ગયો, યાદ આવી ગયું, voltage rule or Kirchhoff's loop rule. જો એક નામ ભૂલી ગયો ને તો મને બીજા બે આવી ગયા, યાદ આવી ગયા. એવી રીતે ઓલો જે છે ને આને Kirchhoff's current rule કહેવાય. What is it called? It is also called Kirchhoff's current rule. Okay, because this is about current, that's why this is called Kirchhoff's current rule. Okay, and this one is called Kirchhoff's voltage rule or Kirchhoff's loop rule. મારા સર હતા ને એવું જોરદાર બોલતા ને, Kirchhoff's voltage લા એવું બોલા, બહુ મજા, એટલું હસવું આવતું હતું ને. તો Kirchhoff તો બોલતા નહીં, Kirchhoff. Okay, so what is this? First of all, again, let me tell you that this is common sense, right? કેવી રીતે સમજાવું તમને? So let's say that this is the shape of some road, all right, or some hill, right? At some place there is some hill, right? Okay, and then after going back, I cannot draw this in 3D. You are coming back. Okay, अरे Kirchhoff French name છે. All right, ના ફ્રેન્ચ નહીં હોય, હા ખબર નહીં, રશિયન જેવું લાગે. Anyways, let's talk about what's the common sense thing. Suppose you would start from here, right? Suppose you would start from here, right? Okay, loop એટલે closed path. Everyone, I hope all of you remember closed path. બરાબર ને? So suppose you are at some height above ground. Suppose you are at some height above the ground. Okay, ક્યાંક ground, આ 3D માં મેં draw કર્યું છે એવું વિચારજો, right? Let's say you are at 10 meter high above ground. Okay, on some, from some figure is not a loop. This person will move in a loop. Okay, આમ ગોળ ફરીને આટો મારીને પાછો આવશે. અરે, let's keep it simple. Drawing એ છોડો. Let's say that you start from one point, okay, and then you go around everywhere, roam around the town, okay, gather some coronavirus and come back to the same point. Okay, right? Then how much is the change in your height from sea level? ખબર ને બધી વસ્તુની હાઈટ sea level થી મેજર થાય. યસ, તને અગ્રી. અરે હું 5 જગ્યાએ આટો મારીને પાછો આવું, 5 જગ્યાએ આટો મારીને પાછો આવું તો ઈ જગ્યા પર આવીએ તો સેમ જ આવે ને. ચેન્જ ઇન હાઈટ from sea level will be 0. Agreed? Yes, height is same as initial and change in height will be 0. Agreed? Okay, so change in height is 0, right? Oh, hey, jordar baki. This is called Kirchhoff's loop rule. खतरनाक. Well, let me make all of you recall a little bit of 11th standard physics. 11th standard માં આવું આવતું હતું કે potential energy of gravity, suppose for simple cases, is mgh. યાદ છે? હા, where is voltage? We are coming to that, right? We are coming to that. Okay, do you also remember that there is something called gravitational potential, which we defined as U by M? Right? So do you realize U by M is G into H and it depends only on H? Right? It would depend only on H. Okay, so જેમ gravitational potential છે એવી રીતે electric potential એ હોય જ ને, right? Yes or no? And even in electric potential there is a property, right? Don't forget, electrostatic fields are conservative. એવું યાદ છે? Right? But here it's not about electrostatics, but still this is true. Here it is not about electrostatics, but it is true. Similarly, it's that if you go around, okay, in a loop and come back to the same point, so just like gravitational potential would be same because height is same, right? You said change in height is 0, so change in gravitational potential is also 0. So just like that, if we go around in a loop, the change in electrical potential is 0. This is nothing but Kirchhoff's loop rule. Okay, સમજાઈ ગયું? હવે સ્ટેટમેન્ટ લખાવું. Again, it is that if you go in a loop, of course you are coming back to the same point, so change in electrical potential is 0. બસ એટલું જ છે. Yes, Chaitya. Okay, so here is the statement. The algebraic sum of changes in potential around any closed path or loop, around any closed path or loop. Okay, having steady current okay, so that's it, right? Algebraic sum of changes in potential around any closed path having steady current is 0. હા તો એટલે જ એ વોલ્ટર લીન ડિસએગ્રી ન કરે ને એટલે જ અહીંયા લખ્યું છે. વોટ્સ ધેટ? ઓકે, પણ બધી વસ્તુ સ્ટેપ વાઇઝ હોય ને અવિનાશ. અત્યારથી હું તમને સીધો ચેપ્ટર 6 સમજાવવા માંડું, હજી તો આ માંડ માંડ આવડ્યું. So algebraic sum of changes in potential around any closed path or loop is always 0, right? See, remember what does this loop mean એ સમજાવી દઉં, then we'll talk about that exception, આવું ક્યારે નો થાય, right? Think of some circuit, right? Think of some circuit, let's say like this, having maybe 1 or 2 batteries, ગમે એટલી ચાલે, એવું કઈ નથી, આ તો ખાલી સમજાવવા માટે જ છે. Let's say something like this, okay, weird shape, A, B, C, D, like that, okay. So what this is saying is, જોજો જોરદાર છે. Let's say you start at A, so you go from A to B, so potential difference going from A to B is VB minus VA. Agreed? We are going from A to B. Current નું નથી કહેતો, right? I am not talking about current. I am talking about, suppose you decide to move from A to B, right? Then the potential difference between these 2 points is VB minus VA. Then you go from B to C. Then the potential difference between those 2 points is VC minus VB, correct? Then you go from C to D, right? Then the potential difference between those 2 points is this. Okay. And finally, you go from D to A. So we have moved in a closed path. So then the potential difference here is VA minus VD. And it is equal to 0. એવું Kirchhoff's rule કહે છે, બોલો. Is this some kind of joke? 0 જ આવે ને કે નો આવે? 0 જ આવે કે નો આવે? તો આ જ Kirchhoff rule છે, right? Yeah. Very good. This will be 0, right? This will be 0. That is what happens whenever there are steady currents. Okay, that is what happens whenever there are steady currents and no changing magnetic flux or no changing magnetic fields or fluxes are involved. Okay, આ બધું શું છે? થોડુંક 10th માં આવ્યું હતું, યાદ હોય તો, કે એક મેગ્નેટ રાખી અને અહીંયા વાયર રાખ્યો હોય અને એમાં બલ્બ લગાડ્યો હોય. Do you remember something like this? And you move this close, then there will be a current in the wire and this bulb might glow if you move it fast enough. Are you aware of this? Do you remember this from 10th standard? Okay. Right. No problem. Even if some of you have forgotten it, don't worry about it. All this is subject matter of chapter number 6. Okay, right? So until chapter number 6, this is fine. કારણ કે આમાં જો આમાં બેટરી તો છે નહીં, બેટરી નથી ને, અને તોય બલ્બ ગ્લો થાય તો એ તો ખતરનાક વસ્તુ થઈ ને. ઓકે, so at that time we'll worry about that. Right now this is true. Okay, so that's why I said whenever there are steady currents, right, and there are no changing magnetic fields or flux, right, this is okay, this Kirchhoff rule is correct. Okay, so right now we will assume that it is correct always, right? Exceptions આવશે એ 6th chapter માં ત્યારે જોયું જશે. Okay, so don't doubt the validity of this rule right now. This is true, right? This is true, but you should know the condition. In what condition, that I've already told you. Okay, yes, Kodal, do you want to ask anything? Fine. All right, so these are the two rules. Okay, actually listen to this carefully, everyone. લખવું હોય તો ક્યાંક લખી લો મોટું heading મારીને. Both rules are only valid for steady currents. I'll just take a moment to explain what is a steady current. Steady current means constant. Okay, current, right? A current that does not change with time. Steady એટલે constant current. Okay, please don't forget that. Now this rule is okay, right? This rule I think all of you would have understood, right? Second and first both બે તમારી common sense માં બેસી ગયા બરાબર? Sure, everybody? Now I will show you how we can use these rules. I'll show you how we can use these two rules to find out currents and such things in complicated circuit જેમાં series parallel ગોતતા ગોતતા વરસ નીકળી જાય. Okay, basically there are some complicated circuits where there is no series parallel, એટલે એવું તમે કંઈક કરી જ ન શકો, ગાંડા થઈ જાવ એવું બધું કરવા જાવ તો, right? So at such places we have to use Kirchhoff's rules or laws. Okay, the two laws, right? So now we are going to learn how to do that. Okay, right? So put the title, how to use Kirchhoff's rules. How to use Kirchhoff's rules. All right, આ બહુ જ સરસ પાર્ટ છે, બુકમાં સેજે આપેલો નથી, એટલે આમ તો આપેલું જ છે, કંઈક એક્સ્ટ્રા નથી સમજાવતો તમને, પણ એકદમ વ્યવસ્થિત તમને લખાવડાવું છું, તમે ગમે ત્યારે વાંચશો તો તમને આવડી જશે, right? So okay, so that's what we are going to do, right? So first step is, like as with complicated things, it's always good to start with example, right? So what I'm going to do is I'm going to take a circuit here, right? I have it ready with me, right? It's a very well thought of circuit. So all of you please draw the circuit diagram, right, as I draw it. Okay, right? So draw it exactly as I've drawn. બહુ પછી આડું અવળું કરતા નહીં, નહીં તો તમને તો નહીં આવડે, પછી બીજા કન્ફ્યુઝ થશે, તમારી સાથે કંઈક ડિસ્કશન કરી લેશે તો. Okay, so please be careful, you do it exactly as I am doing. Okay, right? So this is what we have, right? Suppose this is a circuit. So let's learn how to use these rules by using this circuit, right? So the first step that you should always be doing, listen to this. First step that you should always be doing is, if it is possible to say series parallel, then just decide it, it would be easy. But you're soon going to find that it's not possible. For example, if you say 5 ohm and 20 ohm are in series, well, that's wrong, because for series I've taught you that there should be no branch in between. અહીંથી આમ જાઓ તો વચ્ચે branch આવી, so that's why 5 ohm and 20 ohm are not in series. Just like that, these 5 ohm and 10 ohm are also not in series. Is it clear? હવે વાત રહી પેરેલલ ની. ઘણા તો કૂદવા માંડ્યા છે, સર સિરીઝ નથી તો પેરેલલ. There is no way that 5 ohm can be in parallel with 20 ohm, right? એવું તો સહેજે દેખાતું નથી. So that's what I was saying. In complicated circuits, it's not possible to decide series and parallel because it's not there, right? This is not simple that you could just say series parallel, right? એટલે ઈ કઈ નહીં ચાલે. So we have to use Kirchhoff's rule. Are there other methods? Yes, there are many other methods, right? But uh, as time will come, I'll tell you about those as required. Okay. આજ સમ મને કોઈ પૂછે તો હું તો કિર્ચોફ રૂલ થી નો જ કરું, right? Yes, correct. It's neither nor series nor parallel, right? If someone would ask me to solve this question, I will not do it by Kirchhoff. Okay, that I guarantee. But what's the other method I will use? Well, you'll know it gradually. Okay, so first of all, let's learn how to use the rules. Step 1. Now see, this is like a fixed procedure. આમ કરવાનું એટલે કરવાનું જ હોય, પછી એમાં ચૂંચા નહીં ચાલે, right? Of course, I'll explain why we should do it like this. Okay, so step 1, wherever you are seeing wires, okay, or resistors, wherever you are seeing wires or resistors, you should be able to put some current. Okay, just assume symbols. So for example, between A and B, I am going to say that the current is I1, and I'm assuming that the current is like this. Assuming, everyone. Okay, so that's the step 1. Assume currents in each branch as required. Okay, taking care of junctions. So that is basically use Kirchhoff's first rule, right? That is called KCL for short. I hope you understand. KCL, Kirchhoff's current law or rule. Okay, Kirchhoff's current law or Kirchhoff's current rule. Clear? So take care of junction. So what do I mean? Suppose here I'll assume it is I1. So અહીંયા I1 આવશે. I am sure you get that. Remember, we are assuming. હું એમ નથી કહેતો કે આ રાઈટ સાઈડ હશે, ખબર નથી, મને તો કંઈ જ ખબર નથી. I am being very honest, right? I let everything be done by maths. Okay, we'll leave it to it, right? તમે અંતર્યામી હોય ને તમને પહેલાથી ખબર પડી જાય, then no problem. Okay, and here I'm going to assume that current is like this, I2, right? So પછી અહીંયા હું I3 નહીં લઉં, that is stupidity. It is not wrong, it is stupid. Here we should take I1 plus I2. How many of you have understood this? How many of you have understood this? અમુક લોકો તો આજે વયા ગયા. વાહ ભાઈ વાહ, શું વાત છે. Right, we have used Kirchhoff's current rule, okay, or junction rule. I hope you understood that. D is a junction, right? Okay, so here what will be the current through this resistor? What will be the current through this resistor? Come on, what will be the current through this resistor? Same, very good, I1 plus I2. Okay, now the same current will go here because there is no other way to go, right? Okay, now if it was I1 here, it would be I1 here also, and it would be I1 here also. Agreed? Right? Okay. So again you are seeing that based on junction E also, if it is I1 plus I2 coming in, then the sum of incoming currents should be same as sum of outgoing currents. How much should this be? What do you think? No, Swarali. Yes, I2 will go up, right? I2 should go up. Again, have a look. Sum of incoming. What is incoming? This is incoming. And this is outgoing. So this is also outgoing, right? So that outgoing should be equal to I2. So that total matches, right? Okay. So ultimately, this is also I2. Yes, of course. Of course. Because it was I2 over here also, this will also be I2. So finally, do you see that everything has fallen in its place? બધો હિસાબ બરાબર થઈ ગયો ને, રાઈટ? ક્યાંય ગોલમાલ નથી થતી. અગ્રીડ? સપોઝ આપણે અહીંયા કંઈક આવું આવ્યું હોત તો, then this would be weird, right? Okay, this would be weird. So it's of course wrong. It should be I2. Clear? So ultimately this is your check. If you can do everything, and there is no problem anywhere, if you can do everything and there is no problem anywhere, okay, then if you can do everything and there is no problem anywhere, then that would mean that all the current distribution is correct. By the way, this step one is called current distribution, right? This step one means you are doing current distribution, right? Okay, fine. So that's step one. Step one is very crucial. If you do step one wrong, you have no hope, right? You cannot do anything correct later on. Step three. So sorry, step two. You must get the step one right. So now in step two, what we'll do is we'll choose any loop. Okay, you have to select or choose any loop. Okay, any loop, remember, and decide to go clockwise or anti-clockwise. Okay, this is compulsory. That's what you have to do. You can choose any loop and decide to go clockwise or anti-clockwise. So what do I mean? So here, that's why I have written so many letters. It will help. So first of all, we will choose the loop A, B, C. Okay, let's take a shorter one. A, B, E, F, A. All right. So here I'm going to write it. We will take the loop A, B, E, F, A. All right. I hope all of you see where that loop is. A, B, E, F, A. Right. So automatically I've chosen this direction. So you draw it like that. Okay. You draw it on the inside so you know what you are doing. Right. So we are going A, B, E, F, A. That is, we are going clockwise in that loop. Clear? આવું લખી નાખો એટલે પછી કઈ ડાઉટ જ ન રહે. A, B, E, F, A. પતી ગયું કામ. Right? Now, step 2 is done. Loop has been decided. गोलमाल कहीं નથી Avinash. The Kirchhoff rules are correct, but you should agree with that condition, right? If you don't mention condition, everything is wrong. No, no Coral, it's not necessary. એક લૂપમાં એક જ ડાયરેક્શન ફિક્સ. હવે બીજું લૂપ લઈએ ત્યારે બીજું ડાયરેક્શન તમે લો તો કઈ વાંધો નહીં. ઓકે, બટ ફોર ધીસ લૂપ કાંઈ કોઈ પ્રોબ્લેમ નથી ચૈત્ય. એવરીથિંગ ઇઝ નોર્મલ, એવરીથિંગ ઇઝ ઓકે. બરાબર, કોઈ જ પ્રોબ્લેમ નથી. Remember, before you get the final answer, Kirchhoff rules will not be able to tell you whether you have made a mistake or not. Let me tell you that. Okay? And in fact, you don't even need to worry about the mistake, right? So step 3. So the step 3 is that now we are going to use Kirchhoff's voltage rule, or the second one. Okay, the second rule. Clear? Right? For this loop, we chose a loop, and now we are going to use Kirchhoff's voltage rule for that loop. Okay, હવે એની અંદર પાછા બે પાર્ટ છે, right? Okay, for resistors you have to follow this procedure. For resistors or resistances, you have to follow this procedure. Okay, what's that procedure? 1. If we move in direction of current, okay, then we write minus IR. If we move, Himani and everyone else, right now we are talking about the loop ABEFA. Okay, right now we are talking about the loop ABEFA, right? So what it means is we are going in this direction. Current may be in any direction, we don't care. I repeat, here we have choice કોને કહેવાય? આપણે જે કરવું એ કરો. તમ તારે ક્લોકવાઇઝ લો, તમ તારે એન્ટી ક્લોકવાઇઝ લો, જે લેવું હોય લો, કઈ વાંધો નહીં. એ જોવાની જરૂર નથી કે કરંટ કઈ ડાયરેક્શનમાં છે. અગેન, right? This anti-clockwise depends on your wish. Understood? બીજું કઈ જોવાની જરૂર નહીં. Is that okay? It has no relation with anything, right? This direction has no relation with anything in this whole world. Okay, એટલે બીજું કઈ ટેન્શન નહીં લેવાનું, right? Okay, so I was saying that you move in direction of current, then you write minus IR. Okay, then you write minus IR. If you move in direction opposite to current, then you write plus IR. Is this clear? પહેલા બધું સમજી લો, શું કરવાનું એ સમજો. All the whys I'm going to answer next time. Okay, why like this? Okay, I'm going to answer that the next time. Okay, એ કેમ પાછળ રાખું ખબર છે? Because I have noted over the years that only 10% of students bother about the why, right? And most people also forget that why by the time of exam. So now for batteries or cells, છે બહુ ઈઝી હો, તો એ લોકો ભૂલી જાય. ખબર નહીં કેમ, મને ભણાવતા નહીં આવડતું હોય, હું એવું માનું છું, right? So now what's the procedure for battery or cell? If we move from positive terminal to negative terminal. Okay, current ની વાત નથી ચાલતી હો. If we move, right, if we move from positive terminal to negative terminal, then we write minus epsilon people. ઓકે, ઇન્ટરનલ રેઝિસ્ટન્સ હોય તો એ અલગ ગણવાનું જ છે, એ ભૂલી ન જતા. રાઈટ. સેકન્ડ, opposite of this, if we move from negative terminal to positive terminal, then you write plus epsilon. Okay, so that's the step, right? That's the step. Clear? Okay, and finally the last step. When you move around the loop, okay, writing all these things, and you come back to where you started. Okay, right, when you move around the loop and come back to the starting point, to the initial point, you put right hand side of equation as 0. ઘર મળી જાય ને તો 0 લખ નાખવાનું, બરાબર? એવું યાદ રાખજો, ઘર મળી જાય તો 0 લખી નાખવાનું. ન મળે તો શું કરવાનું? તો પછી ચિંતા. That we will talk about later. Okay, પહેલા આ શીખી જાઓ, પહેલા ઘર મળી જવા દો. Okay, so now let's follow this whole procedure. Let's follow this whole procedure for one loop. Okay, પછી બહુ ફટાફટ તમને આપું છું કરવા, તમે સાચું કરો છો કે નહીં, right? Okay, all these are important points, right? They are golden sentences of our class. આ બધું એકદમ વ્યવસ્થિત વિચારીને હું તમને લખાવું છું, બરાબર? બુકમાં તો આટલું 2 લાઈનમાં પૂરું થઈ ગયું હશે, I am sure. Okay, right? I hope everyone is ready. Let's start. So we are going to use this loop. Okay, હવે મને જગ્યા થોડી ઓછી પડે છે. I'm zooming out so that I can see both together. Can you still read everything, or is it too small? Fine. Okay, fine. All right. Okay. Sure. So we are going on the loop A, B, E, F, A. So first of all, let's go from A to B. Enjoy the ride. A to B. So look at this. We are going in direction of current that we assumed. Agreed? We are going from A to B. We are going in direction of current. Yes or no? So if you go through a resistor, then you write minus IR. But that I is I1 and that resistance is 10 ohm. Is this clear? હજી તો A થી B જ પહોંચ્યા છીએ. Okay, right? So here we have used the rule for resistor. What is that rule? It's that if you go in direction of current, then you write minus IR when you cross a resistor. Okay, now next, now we are going from B to E. Okay, we are going from R to A to B. Away B to E. Okay, B to E. Right, what's the adventure waiting for us in B to E? Okay, no resistor. no bumpy ride, only a good old battery. But look at this battery. Let's zoom into it. Okay, right. So look at this battery. શું રિપીટ કરું? In A to B, we go through resistor. So for resistor we write minus IR. Correct? એનો rule follow કરવાનો. જોતા રહો અંદર. Rule book માં જોતા રહેવું પડશે. બરાબર? Now we are going from B to E. બરાબર ને? We are going from B to E. So first when we come off like this, અહીંથી આમાં આવવાનું છે તો પહેલા પોઝિટિવ ટર્મિનલ આવે પછી નેગેટિવ આવે. So we are going from positive to negative, correct? We are going from positive to negative. So because we are going from positive to negative, we shall write minus 10 volt or minus 10. ખાલી EMF જ લખવાનું છે minus 10. Clear? No, Cordell, you are wrong. It will not be 10I2. See, this has no relation with current because here it's a battery. Between B and E, when you go from B to E, we are going through a battery, right? We are going through a battery. એટલે -10 જ આવશે ખાલી. કરંટ સાથે કોઈ લેવા દેવા જ નથી. Clear? Then now it's time to go from E to F. It's time to go from E to F. બોલો E થી F વચ્ચે શું આવ્યું? Yes, Dhaval, very good. Between E and F there is resistor. Between E and F there is resistor. And we are going in direction of current. Correct? We are going in direction of current. So we should write -20 or minus I1 into 20. Is that clear? Minus IR. Right? We are putting minus IR. Clear? And now last part, F to A. Now we are going from F to A. Okay, we are going from F to A. વચ્ચે શું આવે છે? વચ્ચે શું આવ્યું? F to A માં battery, but this side is positive, that side is negative, right? Again, don't look at the current. When we are talking about cell or battery, don't look at the current. So we are going from positive to negative, F to A, from positive to negative, right? So that's why I should write -5. Okay, I should write -5. I hope that is clear. We are going from positive to negative. જ્યાં 2 આવે ને ઈ જોવાનું, બરાબર ને? From positive to negative, right? So negative. Okay. હવે ઘર મળી ગયું, આવી ગયા પાછા ઘરે. So put equal to 0. Clear? So you put equal to 0. Right? Okay. So this is how you make equation. Right? This is how you make equations. પછી આને સોલ્વ કરવાની હોય એટલે કરંટ ની વેલ્યુ મળી જાય. ઓકે, પછી આને સોલ્વ કરો તો કરંટ ની વેલ્યુ મળી જાય. રાઈટ? બટ નાઉ એઝ હોમવર્ક, જો આ પ્રેક્ટિસ નહીં કરો તો કોઈનું કામ નથી, આવડી જ જાય. ઇટ્સ વેરી વેરી ટફ. It is very very tough. Concentration જોઈ, રાઈટ? કોન્સન્ટ્રેશન જોઈ. ના ધવલ, એવું નથી, આપણે ગમે એ બાજુ જઈ શકીએ, એવું કંઈ નથી. You can go anywhere. So now this is your homework, everybody. You have to do it for the loop. હું કહું એવી રીતે જ કરવાનું, ઘરનું અલગથી નહીં કરવાનું. હું કહું એમ જ કરવાનું, કમ્પલસરી. You have to do it for the loop. You have to do it for the loop EDCBE. બરાબર, આ હોમવર્ક છે તમારું, મને ઇક્વેશન તમારે કહેવાની છે, રાઈટ. You have to do it for the loop EDCBE. Clear? Okay, so with that we're going to stop over here. અરે આ કોમન સેન્સ જ છે પૂર્વેન્દ્ર, કોમન સેન્સ જ છે. હજી મેં તમને આનું કનેક્શન નો કરાવડાવ્યું ને એટલે તમને એવું લાગે છે. That we will do when I'll tell you why, you will understand that this is so natural, right? As much natural as Patanjali's natural products, right? Okay. Goodbye everyone. In EDCBE, there is a battery. Between E and D, there is nothing, right? Between E and D, there is nothing. Between C and B, there is nothing. So you don't have to worry about that, right? Got it, Sorali? Right. Okay, okay, fine.